All right, example 2. Let's find the volume of the right triangular pyramid whose base is a right isosceles triangle, whose non-hypotenuse side is 5 centimeters if the pyramid is 10 centimeters tall. So I drew a picture of this just to get an idea. So it's a pyramid. The base is a right triangle, which is an isosceles triangle. So the non-hypotenuse sides are 5 centimeters, and then the height of the whole thing is 10 centimeters. And then I drew it over here on the XY axis just because that's the way we're going to think about it when we do the volume. So again, remember the formula for this is that we're going to have the volume goes from A to B, the area of a function which describes a function of x which describes the area, and we'll take the integral. Okay, so let's think about a cross section of this. It's also going to be an isosceles triangle and a right triangle everywhere, but it's going to change shapes, change size as we go down. All right, it'll be almost non-existent down here, and it'll get up to 5 by 5 up here. So the question is, what is the area of this? Well, we know it's 1/2 base times height, because that's the area of a triangle. Well, these two should be the same length. But then what is the base and the height, right? Well, we know it's an isosceles triangle, so we know if we know the base, we know what the height is. So one way to do this is to figure out what the equation of this line is, right? What is this line? And we can do that because we have 2 points. We have the point 0, 0. And we have this point, and we know what the x and y values for this point are. We've gone out 10, and we must have gone out 5. So what is the slope of this line? The slope is the change in y over the change in x. So the change in y is 5 minus 0. The change in x is 10 minus 0. So it's just 5 over 10, which is 1/2. And we know that the y-intercept is 0 because we're going through the point 0, 0 down here. So the equation for this is y equals 1/2 x. And so that's the equation of that line. And so this is what we're going to use for the height of the triangle, because notice at each value of x, to get up to that line, we have to go 1/2 x. So that's telling us that both the base and the height are 1/2 x at every value of x, because it's an isosceles triangle. Okay, so then what does that make the area? Well, the area is 1/2 base times height. So we have 1/2 base height. The base and height are the same. They're just 1/2 x. 1/2 x. So the area, if we simplify this a little bit, is 1/2 times 1/2 times 1/2, which is 1 over 8, and then x times x, which is x squared. All right, so this is the function we're taking the integral of. So the volume is going to be the integral of 1/8 x squared dx, and then our bounds are x values, so we start at 0 and we end at 10 because we laid it on its side. And this is not the only configuration you can use, but this is one of the easier ones to use. So I'll pull the 1/8 out. We're going from 0 to 10. This is x squared dx. So I have 1/8, 1/3 x cubed again is the antiderivative. Let's see. Let's multiply these two fractions together. So I get 1 over 24. And I'm doing x cubed, 0 to 10. So 1 over 24, 10 cubed minus 0 cubed. So the nice thing, 10 cubed is 1,000. And 0 cubed is 0. So 1,000 over 24, which simplifies to maybe 175 over 3, and we're talking about centimeters cubed.